Hello everyone, welcome back to my channel, and today we are going to start our new chapter, that is language of chemistry, and I am Prakriti. So it might heard a very boring and a lengthy chapter, but I am promising you that you are definitely gonna like it and you're definitely gonna find it interesting. So let's start our chapter. So first of all, the question is that what is a chemical reaction? So a chemical reaction is the one in which one set of chemical substances gets transformed into another set of substances with totally different properties. With totally different properties. For an example, hydrogen H2 plus Cl, that hydrogen plus chlorine becomes hydrogen chloride. Hydrogen chloride, HCl. So hydrogen plus chlorine becomes hydrogen chloride. Or let me give you a simple example, that is just a minute. Yes, so a simple reaction, that is H2, that is hydrogen, plus O2, that is oxygen, becomes H2O, that is water. H2 is water. So hydrogen and oxygen are gas, and water, as we all know, it is a liquid. So hydrogen and oxygen, they both have different properties, and when we combine them together, it forms water, and water have completely different properties from hydrogen and oxygen as per the definition. So what is a reactant and a product? So reactant, a substance that enters into a chemical reaction, that is called a reactant. As we have an example we have taken an example of hydrogen and oxygen. So hydrogen and oxygen are the reactant, and the product or the final result, we say that the final result is the product. So we can say that H2 plus O2 are reactants, and the substance that is formed, that is H2O, that is water, is a product. It is a product, and these both are reactants. Now let's move to the next slide. So these are the conditions necessary for chemical reactions. So first of all, it's contact. The reactions should be in close contact to initiate a chemical reaction. So almost all the chemical reactions need contact, because without contact, a chemical reaction cannot be happened. For an example, we can see here that sodium plus water becomes sodium hydroxide plus hydrogen. And we have seen that sodium and water are the reactants, and sodium hydroxide and hydrogen are the product. Now, solution of reactants. Some chemical reactions proceed only when reactants are in solution form. For an example, here we can see that sodium chloride plus lead nitrate is sodium nitrate and lead chloride. We can see here that chloride, sodium chloride, so the chloride over here have come to lead here, lead with lead, and the nitrate with lead have come with sodium. Now we will come to heat. So there are many chemical reactions which do not happen without the presence of heat, and we can also associate this to our daily lives. For an example, burning and cooking. So burning of matchstick and cooking of food, these are the examples which we can associate with our daily lives. So let's move to the next slide. So these are some more conditions that are light, catalysts, and electricity. So first of all, we will start with light. So many chemical reactions, many chemical changes only takes place in the presence of light. The reactions that take place in the presence of light are called photochemical reactions. So photochemical, so the question many times comes that the reaction which take place in the presence of light is called dash the photochemical reaction. It's the answer. And the best example is photosynthesis for light, that is photosynthesis. As we all know that what is photosynthesis, that when green plants prepare their own food in the presence of sunlight is called photosynthesis. Now catalyst, it's a new term for all of us. That what is a catalyst? So substances which change the rate of a chemical reaction without themselves undergoing any chemical change are called catalyst. For an instance, we can see that potassium chlorate in the presence of manganese oxide becomes potassium chloride plus oxygen. So catalyst is not always necessary, because if we do this chemical reaction without manganese oxide, it would happen. But to change the rate, if we want the rate of the chemical reaction to be faster, so we have taken manganese dioxide. So it may or may not contribute in a chemical reaction, but it's not always necessary that it always not faster the reaction, but it could also slower the reaction. Now we have an example. Now we have the condition, that is electricity. Many chemical reactions happen only when an electric current is passed through the reactants. For an example, here we can see a water. When electric current is passed through water, hydrogen and oxygen are formed. When hydrogen and oxygen are in close contact, water is formed, and when electric current is passed through water, hydrogen and oxygen are formed. Now, change of color. Change of color these are the characteristics of chemical reaction. These are for change of color, change of state, change of smell, heat is released, heat is absorbed, formation of precipitate, and evolution of gas. So we will start with change of color. So change of color. So for an example, we can say that copper sulfide plus hydrogen sulfide becomes copper sulfide plus sulfuric acid. So I couldn't give the chemical equation over here because it would occupy a lot of space. That's why if you want me to make another video with all the examples for characteristics of chemical reactions, you make a comment down below so that I could make a video. Now, second is change of state. Change of state is also happens in many chemical reactions. One of the most common, not common, but suitable example is hydrogen plus oxygen, which becomes water. So H2 plus O2 becomes H2O. Yeah, I'm gonna erase it because it is occupying a lot of space. Yeah. Now the third one is change of smell. So change of smell takes place in rotting of eggs. Because chemical reaction took place in eggs, that's why it rots. So a smell, it begins to smell. So there is a change of smell. Now evolution. Now its heat is released. Just a minute. Heat is released. So the reactions in which heat is released are called exothermic reactions, and an exothermic reaction causes rise in temperature. In the next slide we will discuss exothermic and endothermic reactions, so don't worry. And the next is heat is absorbed. The reactions in which heat is absorbed are called endothermic reactions, and an endothermic reaction causes fall in temperature. In this, it causes rise in temperature, and this fall in temperature. Temperature falls in endothermic reaction. So heat is absorbed in endothermic reaction and heat is released in exothermic reaction. Now, formation of precipitate. So there are also chemical reactions in which formation of precipitate takes place. So for an example, silver nitrate plus lead sodium chloride becomes silver chloride, that is a white precipitate, and sodium nitrate. Normally the precipitate is white in color, but sometimes it also could be in a different color like yellow. Now, evolution of gas. So I also wanted to mention in formation of precipitate that we would indicate the formation of precipitate by a down arrow and evolution of gas with the arrow up arrow. Yes, so for an example, for evolution of gas, ammonium chloride, when ammonium chloride is heated in a very high temperature, so that is 340 degrees Celsius, and then heat is released, and ammonia, that is a gas with the symbol up arrow is indicated, and plus hydrogen chloride that is formed. Now next slide, let's move to the next slide, that is endothermic and exothermic reactions. So energy is conserved in chemical reactions. The total energy of the system is the same before and after a reaction. So here we can see that endothermic and exothermic reactions, in which the endothermic reaction is cooler than surroundings and exothermic reactions is hotter than surroundings. So here is an example of ice. It is an ice. So in this, heat is absorbed. So here is an arrow indicated like this, yeah, inwards, and here is an example of fire in which the arrow are outwards, which means heat is released. So the ice is an endothermic change, melting of ice is an endothermic change, and burning of fire is an exothermic change or combustion. Now, what is a chemical equation? So a chemical equation is the symbolic representation of a chemical reaction in the form of symbols and formulae, wherein wherein the reactant entities are given on the left hand side. So reactant entities are given on the left hand side and the product entities are given on the right hand side. So here, for an instance, I have taken an example of P4O10 plus H2O becomes H3PO4. So P4O10 and H2O, these both are reactants, and H3PO4 is a product that we all know. But when P4HO10 and H2O are, which are the reactants, so they are always written on the left hand side or LHS side, and H3PO4, that is a product, that is always written in the right hand side or RHS. Now let's move to the next slide, and many a times question comes over from here, that what is a chemical equation. Now this was the end of my slides. So don't forget to subscribe and hit the notification bell. Smash that like button, share to all your family members and friends to spread the knowledge, and also comment down below that how was my PPT, because I have just done so much hard work for all of you to understand this chapter better. And thank you all of you for watching my video, and till then, bye bye.